Lesson 3 of Module 1, our content goal, I can develop an understanding of equivalent ratios by using tape diagrams. We remember that word equivalent means equal. And a tape diagram, this kind of keeps cycling back in Eureka Math. So if you remember, it's a bunch of boxes connected something like this. Let's go ahead and get started. Okay, so exercise 1, follow along in your classwork. It says write a one-sentence story problem about a ratio. So one sentence that I gave us for an example today, and you can go ahead and copy this down. The ratio of the number of sunny days to the number of cloudy days is 3:1. And what that means is for every 3 sunny days, there is 1 cloudy day. Now, if you're somebody who likes a challenge, you do not have to use my example here. You can make up your own one-sentence story problem about a ratio. So you can talk about whatever you want, the ratio of licorice to lollipops, the ratio of elephants to coyotes, whatever you want. I just gave an example today so that I can demonstrate what it means by 2 different forms. So I have written the ratio in one form here, which was 3:1 using a colon. So 3:1. Okay, and then the other way to write that would be to use the word 2. So 3:1. Now, if you wrote your own word problem here, just make sure that the 2 different forms of ratio correlate with the ratio that you put in your word problem. Okay, so now we're on exercise 2 of the classwork. Shani and Mel are using ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7:3. Draw a tape diagram to represent this ratio. So the first thing we want to do is we want to label that we are talking about Shani and Mel. So I'm going to label their names, Shani and Mel. And then right next to their name, I'm going to go ahead and do a tape diagram. So Shani's ribbon is going to be the first number mentioned in my ratio. So she is going to have 7 units. 1, 2, 3, 4, 5, 6, 7. Okay, and then for Mel, she's going to have 3 units because that's the second number mentioned in my ratio. Okay, so here we have represented in our picture a 7:3 ratio, making sure that the names match. Shani is the first person mentioned. The first number mentioned is 7. Shani has 7. Okay, same thing, Mel has 3. So that's our tape diagram. Now what we're going to be doing here is answering some questions to talk about those equivalent ratios. So, and you don't have to write these questions down, but you can kind of solve these with me. The first one says, what does each unit on the tape diagram represent? And we don't know how the length of each unit. So for example, each unit might be 1 inch. Okay, so we could pretend each of these is 1 inch. Because we are talking about length. Okay, so the second one, what if each unit on the tape diagram represents 1 inch? What are the lengths of the ribbon? So if I go through and I write 1 inch, 1 inch, 1 inch on each of these here, and you don't have to write IN for inch, but what would the length of the ribbon be? Okay, so I would have 1, 2, 3, 4, 5, 6, 7. Shani's would be 7 inches, and Mel's would be 3 inches. Oh yeah, because if each unit is representing 1, I know 7 groups of 1 is just 7. I know 3 groups of 1 is just 3. But now, so the ratio of lengths of ribbon, we haven't changed anything, so it's just a 7:3 if each unit represents just 1. Now, what if we change each unit on the tape diagram to represent 2 meters? What would the length of the ribbon be? So now I'm going to erase the inside here, and instead of each unit just being 1, let's take a look if each unit was 2 meters. So what we're going to do is we're going to go back through here, and we are going to put a 2. So now each unit represents 2. I'm working with meters. Okay, so now, if each unit represents 2 meters, what are the lengths of the ribbon? And how did you find that? So we're gonna kind of count it up. I can skip count by 2s. 2, 4, 6, 8, 10, 12, 14 meters for Shani. And Mel's ribbon is 2, 4, 6 meters. And we found that by skip counting by 2s, because now each unit represents 2 instead of 1. What is the ratio of the length of Shani's ribbon to the length of Mel's ribbon now? So now we are no longer looking at a 7:3 ratio. We are now looking at a, scoot this down, we are now looking at a 14:6 ratio. Okay, nothing has changed here so far as how many units that each person has. The only thing that has changed is the value of each unit. Okay, I'm going to do one more example if each unit represents 3 inches. So now instead of 2, we're going to do that one more time, but with 3, each unit representing 3. Okay, so all we're doing here is we're changing the value of each unit. Okay, so if each unit were 3 inches, we're going to go back through. We're not working with meters anymore, we're working with inches. We're going to go back through and we're going to change the value to be 3. Okay, and I can skip count, but I also know a shortcut of multiplication. I know there are 7 units, each with a value of 3. So 7 groups of 3 is 21. So Shani's ribbon is now 21 inches. Mel has 3 units of 3. So 3 times 3 is 9. Not working with meters anymore. So Mel's ribbon is 9 inches. What is the ratio of the length of Shani's ribbon to the length of Mel's ribbon now? So again, we're no longer working with a 14:6 ratio. We are now working with a 21:9 ratio. And here's the 3 ratios we just collected. What do these 3 ratios have in common? I've underlined here, we're going 7, 14, 21. And if you notice, those are all multiples of 7. Here we have 3, 6, 9, and those are all multiples of 3. Mathematicians call these ratios equivalent. What ratios can we say are equivalent to 7:3? So why these are equivalent is because each time here, we never changed the amount of units. We only changed the value. If you notice, I never erased any part of my tape diagram. That stayed the same. I just erased the value of the pieces inside. I erased the value of each unit, but the structure of the tape diagram stayed the same. We are still working with a 7:3 ratio. We are just multiplying whatever value of each unit times 7. Okay, so for example, on this 21:9, where each unit is now 3, 3 times 7 is 21. Okay, and 3 times 3 is 9. So these are equivalent ratios. And just to remind you, equivalent means that they're equal in value. Okay, let's take a look at exercise 3 in our classwork. Mason and Lainey ran laps to train for the long distance running team. the ratio of the number of laps Mason ran to the number of laps Lainey ran was 2 to 3. Okay, and then there is part A says if Mason ran 4 miles, how far did Lainey run? Draw a tape diagram to demonstrate how you found the answer. So let's kind of take this one part at a time. We have Mason and we have Lainey. Okay, so the first thing I'm going to do is write their names. Okay, and the ratio was 2 to 3. The first number mentioned is 2. The first person mentioned the number of laps Mason ran to the number of laps Lainey. So the first person that was mentioned is Mason. Mason has 2 units. Lainey has 3 units. Okay, here is a picture of my 2 to 3 ratio. Now, if Mason ran 4 miles, how far did Lainey run? We don't know that yet. Okay, what we do know though is that here, if there are 2 units, we're going to take 4 divided by 2, okay, and that gives us 2. So I know in each of these units is a value of 2, okay, and if I skip count 2, 4, yes, I get 4. Now Lainey, again, the value in both of these would be the same. So I know that in each unit here, Lainey has run 2 miles, 2 miles, 2 miles to give me a total of 2, 4, 6 miles.